Stop recording too. All right. Well, let's see. I'm gonna have to go check my Twitch stream though. I have no idea if we're live or not. I'm not sure. I'm gonna check my phone. Somebody needs to tell me if I'm live right now. That would be great. Don't know if I am. Oh, I'm live. You know it. You know it. I need like audio checks or something. I don't know if it's good or not. Give me an audio check. Your audio's fine. I actually don't know what you're seeing right now, so I need to figure that one out too. So I'm just gonna go to the stream real quick here, because it wasn't saying that I was live. Oh, okay, now I think it is. Still want to actually see what my stream is. I'm using OBS right now, so I don't know if that's the problem or not. Oh yeah, okay. Alright, so that's what you're saying right now. Okay, that's not too bad. I think we can work with this. Well, whatever. I know how to use OBS briefly, so this is what we're going with. Whatever. I know how to use OBS. Ooh, I do not want to hear my own voice. So. All right, I think we're good to go then. So we should just, kind of start it up. We got 5 viewers. I think that's my entire max. So let's do this. All right, welcome to the stream. Hope you had a good holiday, all that good stuff. So I originally wanted to do this a little differently, but oh well. Oh, speedrun category. How do I set categories? Why don't you just moderate this? I think we need like a moderator here. Okay, hold on. I should be able to do this from my Twitch. Why don't you just info channels? No, that doesn't make any sense. It's just too much. This is too much. I don't think I can do this. No, we're saying screw it. Because I don't want to do this for like 3 hours. So we're just going to get started right away. All right, so let's go ahead and let's do question 1 here. I guess what we'll do here is that I'll explain things as I think about them. We'll do that. If there are like questions about it, suppose we could stop and ask for questions, make a comment on it. I think I have my Twitch, like the stream, the comments are up there, so we'll do it up. Anyways, let's get started. I'm fresh, so I've never actually seen. Well, I have seen this exam, but I haven't actually done it myself. This is the one that the students did last year. So this is you can see January 2018. So this is what the students did last year. This is booklet 1. So I would have an hour to complete this, and I can use a calculator as well. So that's kind of like the name of the game for this one. And yeah, we'll just kind of get started here on this. And I'll just kind of talk my way through of what I'm doing. If there is a question, just pop it on, and then I should be able to get to it. I'll look up briefly every now and then. But we'll get started. So we got question 1. A group of 7 friends decide to go on a movie. Determine how many ways their friends can sit in a row. If 2 of the friends refuse to sit next to each other, it's worth 2 marks. So here's our question of refuse, which we know that we have to do our total minus sit together. So we got 7 friends, so we're going to know that we're going to have 7 factorial for that. And now we're going to figure out what's this sit together is actually going to be. So I'm just actually going to draw it out. I always like drawing these ones out. 1, 2, 3, 4, 5, 6, 7. Let's just say that this is our friends that want to sit together. They can sit in two ways. Either the first one sits down or the second one, and then that. And they can go in a row of 7, 1. They can do 2, 3, 4, 5, 6 different ways. So from this way, it's going to be this all times 6, because there's 6 different ways they can do that. And then we just have to place the rest of the people here. So it's going to be 5, 4, 3, 2, 1. So the sitting together case is going to be my 6 factorial multiplied by 2 factorial. That's going to be a minus. I'm actually going to calculate this as well. It's determined how many. I know in class we kind of just left it like this. However, I'm just actually going to calculate this one out. No, I really don't know what that is on the top of my head. So I'm going to go ahead and use this one. Ah, damn, this calculator. Yeah, I think I can do this way. You should be able to see that. Yeah. Minus open bracket 6 factorial multiplied by 2. There we go. And that should be it. I'm trying to get this 100% done. I'll probably have some communication errors, but I'm sure going to try to get 100% on this exam. So we'll see. If I do make an error, let me know. But I think I should be okay with most of it. All right, on to the other one. Okay, again, we got another question here. We got calculator-based question, 2 marks. Oh, that actually makes me think that we could have just left the other one as 7 factorial minus 6 factorial times 2 factorial. The reason why is because I don't see this calculator sign, but it doesn't really matter. Both are accepted. Okay, we got somebody's listening to the radio at a sound of 80 decibels. She attends a music concert at a sound level of 105 decibels or 115 decibels. How many times more intense is the music concert than it was the radio? Give us a formula, and they kind of like give it all out for this as well. All right, so let's take a look at what we can do for this. Excuse me. We're going to use our formula, and this is going to be our decibels, our B, and then we have I and I naught. Remember, we actually don't have what I naught is. It's just the it's a constant that doesn't change, so it doesn't really matter what it is. But let's kind of figure this out in 2 different ways. We got our first way here, which is going to be our radio. So let's do the radio here, and it's going to be the decibels for the radio equals 10 log. I'm going to use the intensity for the radio divided by I naught. And over here, we'll do the concert. Just going to that Kanye concert. Decibels for the Kanye concert is this. And we'll do the intensity for the concert, I naught. All right. So let's kind of set it up like this, because we do have 2 different decibel levels, and they're going to have 2 different intensities as well. We'll do the 80 for this one. Equals 10 log IR over IO, or I naught. And then for this one, 115 equals 10 log IC over IO. There we go. I'm going to divide by 10 right off the bat. Not really necessary to show that step. We could have actually just gone to this if we really wanted to, and just show log IR over IO. And over here, same thing. I'm just going to divide by 10, get 11.5 equals log. Generally, we don't like to have decimals, but since it's a calculator-based question anyways, nobody cares. I'm going to get rid of the logs as well, so I'm just going to do reverse 7, whatever name you want to call it. But it's log base 10, so this is going to be 10 to the power of 8 equals IR over IO. And this one over here is going to be 10 to the power of 11.5. Okay, now I'm going to read the question one more time, and I'm going to figure out how they kind of want to figure how many more times more intense is the music concert than the radio. So I'm actually going to try to get IC over IR. I think that's what I want to go. That's my game plan. So I'm going to cross multiply by IO on both sides. So I'm going to have 10 to the power 8 IO equals IR. 10 to the power of 11.5 equals, God, they're really making me work for this 2 marks. So then in the end, I want to relate IC over IO equals 10 to the power of 11.5 over 10 to the power 8. The I naughts drop out when I do my division, so I really don't care about that. If I wanted to, I could have an I naught and an I naught there, but they're going to cancel out. And then I'm just going to pop this into my calculator. So let's do 10 to the power of, and I'm just going to do the 11.5, and this is all going to be divided by, now I hope this calculator does what I want it to do, and it doesn't think that I'm trying to do this. That seems reasonable. Equals. Does it give me decimal places? No. So I'm just going to go to 4 decimal places. 776. I'm just going to give it in a little bit of a cleaner form. So the concert was 3162.2776 times as intense. Then the radio. Kind of makes sense. And next time you're at a concert, you'd be like, yeah, that's, 3,000 times more. Oh crap, there was a comment, but I didn't see it. Hold on. I think I actually have a chat over here. Oh, no, I lost your comment. I don't know what your comment was. I'm sorry. You can say it again if you'd like to. Now that I have my chat up my phone, so I have like a thing. But there's your 2 marks there. Okay, going on to the other one. We got another exponential. Okay, so we got solve algebraically. Again, it is a calculator-based question, and damn, that's worth 4 marks. Okay, so we got a lot of work ahead of us. Instantly, I noticed that they're not the same basis, so I'm going to have to use logs at one point in time. Is there anything else that I should do here? Solving for x, obviously, but not really anything else I can do in this case. So I'm just going to go ahead and apply logs to both sides right off the bat. I actually get to choose the base of the logs. In class, we just kind of left it as log base 10. There's nothing wrong with doing a different log base, but I would just leave it as a log base 10 since that's what we kind of did in class. I'm going to say log base 10, 2 multiplied by 7 to the power of x equals a log. It's going to be 3 to the power of 2x minus 3. Apply log rules, so that means I'm going to actually have to split these guys up before I bring the x down, but over here I can just bring that down, that entire binomial. So it's going to be log base 10 of 2, and it should be plus log base 7 power x equals, and I'm going to bring down the entire 2x minus 3 log of 3. All right, now with this being done, I'm going to pop down that 7. I'm going to actually distribute this as well. And then we're going to start trying to isolate for x. So let's get my log base 2. Really irrelevant. It's my constant, so I'm just going to have to kind of tag that along wherever I go. Equals 2x log base 10 of 3 minus 3 log 3. All right. Looks good so far. I'm going to pop over my x's all to the same side and my constants on the other. Whatever, I just see a 2x over here. It's positive. I'm just going to leave my x's on my right-hand side. Feel a little bit more comfortable with that instead. Minus x log 7. I'm going to pop the other one over. So I'm just going to swap places. Like that. Then I'm just going to isolate for x. So I'm going to factor out an x. I guess I should say if anybody really can't read my writing to let me know. Right now I'm just kind of going for speed rather than legibility. Sorry. But that's just kind of where I'm going for right now. Plus my setup is actually super awkward right now because I have this cord that's kind of like hanging from this camera and it's not in a great place. And it makes me writing, my writing really constricted. Just excuses anyways, right? Log 7. These are going to cancel, and I'm going to get log 3 minus log 7. I feel that should be like telling jokes or something, but it just doesn't work like that. Plus, I'm not funny. I'm going to cancel out. And then, yeah, we got what x is equal to. It's pretty ugly. But this is a calculator-based question, so we do actually want to give a final answer. And we're just going to pop this gigantic thing into our calculator. And, yeah. There you go. So let's pop open a calculator and let's go for it. Okay, so here we go. Now there's a smart way to actually put this in a calculator. So brackets are your friends, always your friends. So I'm going to open up my bracket first, and I'm going to go ahead and go log of 2 plus, I screwed it up, 3 log 3, close that bracket, divided by, open up that bracket, 2 log 3 minus log 7. That should be okay. And there we go, 15.8724. I'm just going to pop that over there real quick. X is equal to 15.872. Yeah, you want to round to 3 decimal places or just leave 4. So that would be fine. Now, okay, this is a good place to kind of like just stop and say something here. If I really wanted to, I could go back and plug this in and then make sure left-hand side is right-hand side. And that would just kind of really ensure me that. Whatever, I don't really care right now. If I had time later on, you have this for the full duration. You would want to do this before you go on to the second booklet though, because you still have a calculator at this time. So you could do that right now. I'm not going to. I'm pretty confident in my work. I don't see anything as an error in it, so I'm just going to keep on going. By the way, I do have my formula sheet over here. I haven't actually looked at it yet, but I did take that out of my exam booklet as well. Okay, keep on going here. Here's another calculator-based question. Damn, another 4 marks, man. Okay, so here's my calculator-based question again. What do I see in it? Solve for theta algebraically. Awesome. Over the interval, boom, we got some radians as well. So obligatory radian check. No, I'm in degrees. So I'm going to change my calculator to rads right away. Okay, now we're good to go. Okay, so we've got rads and we're good to go. It's in cosecant. I mean, I could change it if I'd like to, or I can just kind of deal with it in like this way. So yeah, I'll just deal with it like this. I think it's okay. First, what I want to do here is I want to figure out if this is factorable. Having a brain fart here. Oh, it should be 4 and 2. So I'm just going to go ahead and factor this right off the bat. I'm going to leave it in terms of cosecant because I'm pretty comfortable with that. We could let x equal, but in this case, I don't think there's really much point. I'm going to remember to put the cosecant thetas though, because that's important. I don't want to just leave it as cosecant. It's cosecant theta. Minus 2 equals 0. I'm just going to do a real quick check on this one. That makes sense. That looks good. That looks good. That looks good. Equals 0. Always want to make sure that we keep our equation as well. And this is going to split off into 2 types of solutions. We are going to have a cosecant theta plus 4 equals 0. And we are going to have a cosecant minus 2 equals 0. And this ultimately leaves to 2 types of answers. We have our cosecant theta equals negative 4, which is perfectly allowed. I don't reject that answer. And we have a cosecant theta is equal to 2. Again, I don't reject that answer. We only know our boundaries. Well, we might know our boundaries for cosecants as well, but we really only know our boundaries for cos and sine. And this is neither right now. So I'm going to change this into 1 over. Yeah, 1 over sine equals 4. It does not equal the reciprocal yet. Haven't done it. I've just used a trig identity here. Same thing over here. I love how I'm explaining this, even though I know you guys kind of know this stuff. All right, so we're going to do this. Go ahead, and I'm going to make sine into the numerator now. Boom, and then now I'm taking that reciprocal. Now I'm taking that reciprocal. Oh, now I'm taking that reciprocal. Okay, somebody caught that. All right, at this point, now I get to kind of say if I have to reject anything, and I don't. These are 2 appropriate answers. I'm going to have a quadrant 1 and a quadrant 2 answer. And actually, this is an exact answer. This is something that I do know. And I can go right off the bat say that this is theta is equal to, I believe that's a pi by 6 in quadrant 1, and that should be a 5 pi by 6. So I already have this good to go. Now we have to deal with the other side, but unfortunately it's negative, which means that I'm going to have to go ahead and get my reference angle. So reference angle meaning that I'm just going to figure out what this angle would be in quadrant 1, aka positive, and then I'm going to put it into my other quadrants because I know this is in quadrant 3 and a quadrant 4. So let's go ahead. I'm going to take shift, sine, and I'm going to open my bracket 1 divided by 4. I'm doing this off to the side. This is in radians as well. So I'm going to get my theta r equals 0.2526. Good enough. 4 decimal places. You can have more if you'd like to, but I don't really care. I'm going to do my quadrant 3 theta equals, it should be a pi plus reference angle. And then my quadrant 4 answer is going to be 2 pi minus theta r. So I'm going to stick this guy here. And I'm going to go with where's my pi button on this calculator? Pi plus, I'm just going to keep my answer like this. So I'm going to get my quadrant 3 answer to be 3.3942. And I'm going to get, I guess I should have just done that, but I'm going to take my 2 pi, and I'm going to minus this one from it. And I should get a 6.0305. Good. So here's my angles. Boom, 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 boom. But I'm not going to be a slob and leave my answers like that. I am actually going to say my final answer, theta equals, and I guess I'll just keep on going from quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That's it. So that would be my final answer. It's in radians. Done that. Good to go. A lot of marks. Man. Let's get some easy ones here. Hey, 1 marker. I like that. And it is a nice little use your calculator. You ever forgotten the code to unlock your cell phone? You know the code is made up of 4 numbers from 0 to 9. Determine the possible codes if repetition is allowed. Ooh, okay. Here's a nice little thing. Do not think that there is only 9 numbers from 0 to 9. Please think that there are 10 numbers from 0 to 9 into bit, because you can use 0 as a digit on one of your passcodes. Also, it is a code or a password, and this means order matters. So we're going to use the permutations, but honestly, we're just going to use the fundamental counting principle. 4 numbers, 1, 2, 3, 4. That's like our 4 sets or 4 digits in that. Repetition is allowed, so we can have 10, 10, 10, 10 equals, oh, I better not screw this one up, 10,000? 1, 2, 3, 4, sure. There should be your 1 mark. Hey, there we go. Just on the bottom here, calculator is not required for the remaining test questions. I don't know how many questions we just... 5. We only did 5 questions there that we needed a calculator for. This booklet's not done, but it's just saying that now you don't actually need to have a calculator for the rest of them, which is nice. All right, let's move on. Haven't lost any viewers yet, so that's okay. Subscribe to me on Twitch. No, I'm just kidding. All right, let's keep on going here. Binomial expansion. We have this, and that is to the power of n. Okay. The 5th term contains x to the power of 7. Determine the value of n. Interesting. 2 marks. I don't remember the binomial form. I'm going to write that down right now. T k plus 1 equals n. Choose k, a to the power of n minus k, b to the power of k. All right. Here's my formula off the formula sheet. I'm actually just going to list a couple things off to the side here. I know my a value here is actually going to be that first term, 7 over x to the power of 3. I know my b term is going to be equal to negative 3 x to the power of 7. There we go. I need the 5th term, though. Oh, I'm sorry. The 5th term contains x to the power of 7. I need to determine the value of n. Doesn't care about the coefficients, which is nice. So if this is the 5th term, that means that this is t5, and this leads k to be equal to 4. That's, I think, all I really need to get from this. Yeah. We're going to kind of shove everything into this. I'm going to disregard all those coefficients because I don't care about them. And we're just going to kind of see what happens from this. So I'm going to get t5 equals... Don't know what n is, right? I'm solving for n. We know that k is 4, and we know that my a term is 7 over x to the power 3. And again, we don't know what n is, but we do know that k is 4. And we do know my b term. to the power of 7, and this is all to the power of 4. Okay, essentially right now, what I can do here is I'm going to equate this entire thing to, some number, but this is all going to be multiplied by x to the power of 7, because that is my fifth term. Apparently, that's what it has in it. Again, this I'm going to disregard because that's just some number. This 7 I really don't care about because it's not combining with any x's, and same with that -3. I really don't care about because it just has x's. So I'm just going to kind of like reduce a lot of this out to some number, which I don't care about, and it's going to be 1 over, and I'll do this in a couple steps because I think it even might help me just to break this down in my head. X to the power of 7. I've just gotten rid of all of the numbers. I've gotten rid of all the numbers here, all the coefficients, just so that I can focus on what's important, which is just the x values. I'm going to get rid of these guys, and I'm just going to go ahead and say this is going to be 1 over x to the power of 3n minus 12. I've distributed the n minus 4 in my brackets here. And then this is going to be x to the power of 28. I'm going to keep on plugging along at this, and that means this is x to the 28 divided by x to the power. Wow, that's a nasty question. Man, that's a nasty question. Let's go ahead, and I suppose I could just, there's so many options that I can do here, honestly. I would just like to subtract these two together, but I actually can even cross multiply if I really want to. X to the power of 7 multiplied by x to the power of 3n. And this is like, wow, you got to know your exponent rules. If you don't know your exponent rules, like, you're screwed on this question. Regardless, really, of what happens. Now, I have the same base, and I'm multiplying, which means I add my exponents. So I'm going to have x to the power of 3n, and that should just be a minus 5 then. X to the power of 28. Hey, they're the same base. So who actually cares about the base anymore? That's what I got. 3n equals plus 5, so 33. N is equal to 11. Very nice. Again, this is a great time where you can, if you still have your, oh, thank you so much, I love chicken, that if you do have a calculator, you can just go right ahead and you can actually just find, if you want to plug back in n is equal to 11 back up here, you can actually just find the fifth term. And if it comes out with an x to the power of 7, like, boom, you got your answer. You still have a calculator available to you in this half because this hour hasn't passed. I think this hour hasn't passed. So you still have that available to you. You don't need it for this question, though. Let's keep on going here. A 1 marker, given the domain. This screwed up a lot of people. I think this is where one person lost a mark. That usually doesn't lose marks. I'm talking about you, Ellie. Given the domain of f of x is equal to this set notation. Okay, 29 minutes in, thank you. Set notation. And the range of f of x is this set notation. State the domain of the inverse. Okay, so first off, we got to know that this is the inverse. It's not the reciprocal. Swear to God if you guys say it's reciprocal, okay? So this is our inverse. Woo, inverse. Which means the domain and range will be swapped from the original function. Now, this is what we need to do. We cannot use any type of interval notation because that would give us a range of values. We have to keep our set notation here because remember, these are all discrete. So they tried to trick us in this one. State the domain. So the domain of f inverse x is going to be the same as the range. So I'm just going to put domain of f inverse x, and I'm going to put the range of my original f of x. And I'm going to be done. Okay, done. Easy mark. That's just that you got to know that your x's are swapping with your y's there. What? Another form? Okay. Oh, maybe I did that for my exam. Who knows? Okay. Okay, we got a 1 mark. Given the graph, y is equal to fx, sketch the graph of its inverse. Oh, okay. So this is where my xy becomes yx. Honestly, I'm not even going to take any chances here. I'm just going to label out my points and then do it down here. Yeah, there are other ways to do this as well, like doing a reflection along the y is equal to x line. I don't trust myself. I don't trust myself to count. I don't trust myself to do that, especially in a high strung situation. No way. I'm not going to do it. So I'm just going to keep on going ahead with this. Negative 1, 2, 3, 1, 2. Negative 3, 2. We got negative 1. 1, 2, 3, 4. Funny how I do count. Trust myself counting though. We got 1, 4, and then we got a 1, 2, and a 1, 2. Swap them over. 2, comma, negative 3, 4, comma, negative 1, 4, comma, positive 1, and then we got our 2, 2. Put them on. We got 2 and 3, 2 and negative 3. 1, 2, 3. We got a 4, 1, 2, 3, 4, minus 1. We got a 4 and a plus 1. And we got a 2, 2. Now, there is an arrowhead here. I'm not forgetting about that, but I'm just going to go ahead and connect some dots past kindergarten so I can do that. And now we just have to make sure that we extend and doot, doot. And that would have just been a graphing error if you didn't make a communication error. So we're good to go. That's an arrowhead. And hey, maybe I don't know if you know that's an arrowhead. So I'm going to say arrowhead. Yeah. Mark is mine now. Okay, done. Okay. 3 marks. Prove the following identity. Huh. I don't know what side to start with. I kind of want to start with this side. But I almost feel that's a trap. I don't know, I'm going to go back to my formula sheet. Do we have this? Do we have this here? Is that a thing? Hey, that's a thing. I could do that. Does that help me, though? I'm going to roll with it. I'm going to roll with that side. I'm going to roll with that side and just see what happens. I'm going to leave that left-hand side. I'm just going to just chill, buddy. I'm going to go ahead and replace that with plus secant squared theta. Let's see what's going on now. I'm still in the first booklet. Question 9 of, I don't know, question 9 of 14. Okay, whatever. Let's keep on going with this. No more distractions. Okay, 1 over cos theta plus 1 over cos squared theta. I'm immediately regretting my life decisions right now. No, I'm not. I take that back. I'm going to get a common denominator. Haha, I got it now. Common denominator of cos squared theta. Yeah. Now I'm just going to replace my cos squared theta with the Pythagorean theorem, or Pythagorean theory for you peasants. 1 minus sine squared theta. And we got the right-hand side, or the left-hand side. Okay, well, I kind of mixed up those, but that's okay. That's not actually supposed to happen. Okay, shut up. Yeah, we got all our marks here. Here's 1 mark, actually. That's 1 mark. That's your 2nd mark right there, and then you got your 3rd mark there. Good to go. I don't know how many people would have gotten that, though. I guess, maybe they would have taken the other side. I don't know. Just you, Jacob. Just you. Okay. This is actually the one that got a lot of people. I remember this question specifically. And I hope I've taken us home enough to know where the error is. Okay. Thomas used the graph. It's 1 mark. First off, it's 1 mark. So that's a hint. Thomas used the graph to solve this. Okay. They're saying he incorrectly states the solution as negative 2 and 1. Describe how Thomas should have stated the solution. Here you go. Okay. You do not regraph these. There's nothing wrong with these graphs, okay? These graphs are perfect. You're not supposed to redo them because, again, it's 1 mark. But he incorrectly states the solution as negative 2 and 1. Negative 2 and 1. It seems like that is the intersection of these 2 graphs, which would be the solution. However, if you're solving an equation, right? Solving an equation. The only variable that you have in this equation is x. This is not a solution to the equation. X equals -2 is the solution. I don't think a lot of people got this question right. I think this was a very poorly done question all over the exam, not just St. Norbert. This was all over the place. This was a very bad error. Is the solution. The y value plays no part in the equation. It's a describe question. We haven't talked too much about that, but you should know by now if it's like an explain or if it's a describe, you got to say it in words. It has to be in words here. You can always use math to help you out, but in the end, it has to be in words. So x equal 2 is a solution, comma, the y value plays no part in, I'll say solving the equation here. Solving the equation, okay? That's a difficult question, but x equals, that's how we solve equations. And if you're getting from a graph, great, that's the intersection point. We know that's a solution. However, we got to make sure that it is from that. Oh, wait, this isn't on shuffle? Tragedy. Yeah. Yes. Okay. Let's keep on going here. Okay, we got 2 marks here. It looks like, yeah, you guys can see it. Given the graph y is equal to f of s, sketch the graph y is equal to the root of f of x. So here's f of x. We just got to do the root of it automatically. You guys got to know that we cannot take the root of any of these y values. So none of those go away. We can't take the radical of any negative values. So we're going to start there, and we're going to start there. And we have our invariant point at y is equal to 1 as well. Do we have a y is equal to 4? Doesn't really seem like it. We know the graph will extend to there. So I'll just pop a value down here because I know it's being extended from those arrows. So I'll just kind of pop it down here to ensure maximum accuracy. But we have to do right now is make sure that we go above the original and then below it. Above and below. And I'm just going to pop that arrowhead on. Above and below. I'm going to pop that arrowhead right there as well. Don't make any weird curvy things. As soon as you give us a reason to take a closer look at your work, we will. And if you're doing this weird like woohoo thing, no, that's not happening. So just please make sure that you're going just above, but you're not doing this weird like branch out effect. Just going above and then below, above and then below, and then pop your arrowheads on it because boom, boom, we got arrowheads. There you go. 2 marks flying, just absolutely flying now. Okay, we got 2 mark question here. 1 mark. When a polynomial p of x is divided by x minus 2, the resulting equation is this. Explain why is not a factor of p of x. Okay, so this is, again, from one of our first units actually, but this is in one of our forms of how we can do a quotient from a factor and a polynomial, or a dividend, sorry, and a polynomial. This is one of the things that we can express it in. Now it's saying, why is this not a factor? Now, we have to make sure that we choose our words carefully, okay? Explain why x minus 2 is not a factor of it, because a remainder of, and this is another kind of wishy-washy one, because a remainder of 3 over x minus 2 exists. This over here, no, I think I should go get the marking guide for this one. I know this one caused a little bit of problems as well. The answer is either because, I think there's 2 acceptable answers for this one. There is because a remainder exists. Now I know it. Now I remember it. Because a remainder, this is an acceptable answer. The other example would be this. Because a non-zero remainder exists. That would be okay too. I'm trying to think of what the common errors were here. I think they didn't like when you said because a remainder existed, because it didn't sound, you didn't express why this was not a factor. It's not a factor because the remainder has to be 0 if you're a factor, or you have to have a non-zero remainder to not be a factor, if that made sense. They really needed to have either you're describing or you're explaining why that exists, because this is our remainder and that's not a factor, or you're explaining it's a non-zero remainder. So you had to really be precise in what that was. If you said because a remainder exists, they didn't actually accept that answer, which I thought was kind of bullcrap, but that was the name of the game in that case. Okay, determine the equation for the polynomial function px. Okay, right on. So we know from up, I'm just going to kind of transfer it down a little bit here. So px divided by x minus 2 equals plus 3 over. Okay, so we've got to figure out what p of x is now. Couple ways to do this. I think the easiest is just to multiply everything by x minus 2, since we have p of x already isolated over here. So I'm just going to multiply. And remember, it's everything. So we can't just do it to one of these terms. We got to do it to absolutely everything. This is fortunately going to cancel out, but we still have to multiply these two things together, which is an interesting 1 mark, if I have to say so, because this isn't actually anything like grade 12-ish. Plus 3. I'm going to go ahead and just start to FOIL this out. We got a minus 2x squared minus x squared. Lost my place already. Plus 2x plus x minus 2 plus 3. Let's do a little bit of combination here. We got a x to the power 3. You guys probably can't see that. We're going to combine those. Minus 3x squared plus 3x plus 1. That's it. There you go. I think that's going to be the easiest way to do it. Just multiply everything by your x minus 2. Cancel. That gets canceled. You have to multiply this trinomial, though. And a little bit of a pain, but whatever. You get your mark. Okay, determine the equation of... actually, it doesn't look that bad. They look congruent, so it looks okay. I just saw this, and that was nasty. Okay. Let's go ahead and let's take a look at this then. We got g of x in terms of f of x. So I have to describe what this is in terms of that, or determine the equation. Again, this isn't any function that we know. Like this isn't a parabola, this isn't a linear line, this is nothing. So we actually have to use like function notation for this. So we got to figure out what a, what b, what c, what d is in this case. Now, luckily, there's a couple things that we can do here. We don't have to go through this entire process that we did, like we did in this example in class. And I really specifically think that they're not going to give you a question like that, because they're either can give you some shifts or they can give you some stretches. They're not going to do both. That's too much. That's too much. And they won't do that specifically. So in this case, we got a reflection, obviously. I'm just going to kind of write down what I'm seeing here. There's definitely a vertical reflection. Looks to be a vert shift. And is there a horizontal? Yeah, looks to be a horizontal as well. Now, this is your 3 marks, 1, 2, 3, right here, right? 3 marks, we got 1, 2, 3 here. We know that first and foremost, that there's going to be a vertical reflection, so I'm just going to start off with a negative. Now, if I do that, then all of these will go into the negatives, and then I'll have to push them up, I think. That would make sense. So if I do a vertical reflection to this guy, it would be down here. 1, 2. This one, 1, 2, 3. 1, 2, 3. Okay, that would just be a vert reflect. So now I have to make this guy look like that. And that means that I'm just going to have to move it up 1, 2, 3. So that's going to be my D value. And then I'm going to have to move it over 1. Okay, so let's kind of put this down. It looks like it's going to be a vertical reflection. It's going to be a vertical shift. And I'm going to say this is going to be a plus, I think I said 3, didn't I? 1, 2, 3. Yeah, plus 3. And then I'm going to have a horizontal shift. Now, I'm not even going to put a sign here because I'm just going to need to internalize what that sign means. So I'm just going to say towards the right. And it looks like it only needs to do one from here to here. Now, what does this mean in terms of f of x? Well, we know our a value is the same, so we don't have to worry about that. But it's going to be negative f, open bracket, x. Now, I know it's to the right of 1, which means if I'm putting it into my function notation, it's got to be minus 1. That's all I'm doing to my horizontal values, and then I'd say plus 3. That was a tough question. That was seriously a tough question. Makes sense, though. We know that there's a vertical reflection. If I did that, because we know the order means I have to do that one first, what do I have to do to this one now to make it that? We got to move it up 3. That's my d value. And then I have to move it to the right one, which means my c value is 1, but I got to put that negative in there. Not a bad question. Okay, so I must be... What time is it? Oh, 15 minutes afterwards. Okay, so basically I have another around 15 minutes, I'd say, to do 2 questions, it looks like, with my calculator. I can still work on this after the time is done. I just have to actually put my calculator away. You have unlimited time. You have 3 hours to finish this exam, but you only have an hour to use your calculator. And we are so far by those calculator-based questions, so it doesn't really matter at this point. I can take as long as I really want for this. Anyways, let's continue. Explain. Woo! Explain. So that's words. Damn. Why the binomial expansion of this does not have a middle term. There are 10 terms in this expansion. Since this is 9. ... There can be no middle term. That would be enough. You could just say 10 terms. There can be no middle for 10 terms. I've seen people do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And just work their way down. And it's like, uh-oh, no middle. No, this would not be acceptable work because you have to actually explain it, but that can be like your work showing it. How would you explain why there isn't a middle term? So in terms of this, you could say, like, this is your explanation right there. Like, as long as you said somewhere in your explanation, whatever that might look like, that there's 10 terms, that says everything, right? That is your explanation. Hey, there's 10 terms. Can't be a middle term for 10. You could, if you wanted to, you could also say something like this. This would be acceptable. Since n is an odd number, there will be no middle term. That would be fine. That shows all we're looking for here is that you understand that the number of terms in this binomial sequence is even. There's an even number of terms. You could even say that in your explanation. There is an even number of terms, therefore no middle term. This says it as well. Since n is odd number, there would be no middle term. That would be fine because that shows that this has to be an even number for you to have a middle term because there's k plus 1 terms. There's so many different ways to say it, but you basically just need to boil down to linking something over here to either saying that there's going to be 10 terms, no middle. There's an even number of terms, therefore there's no middle. N is odd number, so there's k plus 1 terms, and that means that whatever it happens to be, but you have to somehow link what you see here into that. Hope that answered it. If not, just ask me in class. Yeah. Okay. Oh, wow. This is actually a pretty fun question. I didn't think they were going to ask us this here. They usually do this in multiple choice one, but they're actually going to give us, 3 marks for this. That's a gift. That is a gift from the math gods saying that. Because logarithm expansion rules they're clear cut. Hell, you have them, right? Like, here's your, boom, there's your logarithm expansion rules. They give them to you. You just have to apply them. So that's actually interesting that they have a 3-mark question for that. That's hefty marks. Anyways, let's do it. Actually, can I do that? Nice. Okay, so let's go ahead and let's expand this out. I'm filling the subtraction first. 5 root a minus log b to the power of 3. Going to split it up again. Log 5 plus. Yeah, you know what? Nah, I'm just going to do this all in one go. Done. Like, wow, done. 1 mark, 2 mark, 3 mark. Done. Probably one of the easiest 3 markers that I've seen. Don't have to worry about any brackets. Don't have to worry about anything like that. It's super clear cut. That is book 1. Book 1 done. Again, I don't really have the marking guide, but I don't think we have any problems on that one. I don't think I should have gotten anything wrong on that one. Maybe a communication error. My work was pretty sloppy in the beginning, but I think that was it. Okay, book 2. So we're under an hour. We still actually technically have our calculator. Sorry. As soon as you go to book 2, calculator's gone. So if you move on to book 2, and I'll let people go on to book 2 before the hour has passed, you just have to put your calculator away. So now that I'm done book 1 and we're still under an hour, you could still go back and you could go through some of your answers with a calculator on book 1, because you still have what, like 10 minutes with a calculator. You can still do this, right, and not go on to book 2. But as soon as you pick up book 2, because I'm going to put it by your feet. I'm putting book 2 by your feet. As soon as you touch book 2 and you're saying I'm going to start it up, then your calculator has to go away. You can still have book 1. You have book 1 for the entire duration of the exam, but you only have your calculator for the first hour. So I hope that kind of is making sense. So I'll move on to book 2. So calculator goes bye-bye. Okay, let's keep going. Book 2. All right. Oh, I have a timer on this already. Wow, I'm kind of stupid. Yeah, 51 minutes right now. Okay. First 9 questions are multiple choices, I believe. You would fill these out on a bubble sheet, actually. So we give you a bubble sheet, and you fill them out over here. You can always mark them. Ooh, can you mark them in here? Yeah, you can mark them in here. Yep, you can mark them in here, but you have to mark them on the bubble sheet. So if you don't do that, then you won't get the grades. Oh, hi, Luna. So if you're nervous about bubble sheets, you can put them in here first, and then just make sure you transfer them over afterwards. For right now, I mean, I don't have a bubble sheet, so I'm just going to put them in here. But you would be answering these on a bubble sheet for your final answer. Okay, identify 10 degrees in radians. Okay, we got 10 degrees. We're going to put it into radians, so we're going to say pi over 180, boom, 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 equals pi over 80. I mean, 118, sorry. Done. Polynomial, this has a y-intercept of that. Determine that. Wow, y-intercept, that's like a coordinate, isn't it? I think it is. So we got negative 8 is equal to a, negative 1 squared, 4 something. Who cares about that? 16, we got negative a half. Why am I even doing multiple choices? It's like a waste. It's like a waste of time right now. It's actually pretty fun. Okay, keep on going. Identify the value of, ooh, hello. No. Actually, no. It's just, no. Okay. Given the angle 25 pi divided by 7, identify a coterminal angle on the interval of, oh, okay, cool. So this is obviously well over 2 pi. So I got to subtract 2 pi's to get it within this one, because this is 0 from negative 2 pi, or negative 2 pi to 0. So I'm just going to keep on subtracting values of 2 pi until I get there. I'm not going to leave it up to me doing it in my head, because sometimes my head's crazy. So I'm going to leave it like this. And I'm just going to, whoa, and I'm not even going to do that way. I'm going to do it this way. Yeah, okay. Now we know what's on the level here. Good, I'm going to do it one more time. Minus 14. I don't like this. I don't like this at all. Negative. There we go. Negative 3 pi over 7. See, I don't leave things up to chance. I let my math do the work in here. Good. Just subtracting values of 14 pi over 7. Identify which expression cannot be evaluated. We're looking for a k value that's higher than our n value, right? Because this is n pk, and n always has to be greater than k. Yeah. Okay. Good stuff. Ooh. Hello. Interesting. Okay. Let's see what we know about this. We know that there is a horizontal asymptote. Y is equal to -3/2 because they're the same degree. So that's at -1.5. So that automatically... Does that automatically just give us our answer? Whoa, I think it does. I think it's B. Just from that. That's the only one that has a horizontal asymptote of that. Now, I feel a little... No, they all have... Yeah, they all have vertical asymptotes. A VA x is equal to -2. They all have that one, so that doesn't mean anything. I suppose if I really wanted to, I could actually plug in some values and actually see if there would be. This one does make sense, though, because it has a 0, 0, and if I plug in 0 for x, I do get 0, 0. So that makes sense. This one does have that as well, but that's a positive. And I'm really confident that my horizontal asymptote is at negative, so I'm just going to go with B. Oh my god, did I gain a viewer? Nice. New record. Subscribe to my Twitter. No, I'm just kidding. Okay, given a point, -2, 0 on the graph of y is equal to fx, identify the coordinates of the corresponding point on... Ooh, this is fun. Boom, boom. So I'm going to go ahead and put my xy, and I'm actually going to go and give my mapping notation for that based upon an a and b value. So this is going to be 2x, reciprocal of that one, and I just trust whatever the a value is. I don't have to take a reciprocal. So -2 and 0, that is actually becoming -4 and 0. Sweet. Identify the non-permissible values of theta over this. You got a lot of options, but we got to know that this whole denominator cannot equal 0, which means sine theta cannot equal -1, which means theta cannot equal 3 pi by 2. I was almost going to say pi by 2, but I didn't, because we're burning chrome. All right. Identify the function with asymptote x is equal to -3. Derp. Yes. Correct. Because, right. Cannot take the log of 0. And this one is log x and then plus 3. Right, okay. And that's, okay, we're good to go. Ooh, threw for a loop. Okay, evaluate the following expression. No. Okay. 3 marks. It's a lot of marks. Oh, really? They're going to make us do that one? Jeez. All right. I'm going to act like I don't know what the exact value is, which is truthful, because I don't. Hold on. Pi by 3, that's in the second quadrant. I'm going to guess it's -√3. We're going to see. We know this one, however, is going to be -√3/2. And we know down here, hope I'm not doing this wrong, that's going to be -0.5. Something more doesn't make sense. Because it's not negative. Okay. Hey, yeah, I think I was right. -√3. Got him. -√3. That was really the only challenging one, I'd say. Afterwards, we get to figure out what cosecant -2. Oh, that's actually throwing this one for a loop there. It's giving me a little negative. Giving me a little sass there. That's okay. Because it's pretty easy anyways. That would be in my third quadrant then, if I'm going around like that, -2 pi over 3. So sine coordinate would be 1 over -√3/2. So this is going to be a 2 over √3. Pop that negative in there because it's the reciprocal of it. So, yeah. Cos 3 pi, -1. Yeah. 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 Okay, cancel. We get a 2 plus... Yeah. You know how many people thought they got the wrong answer when they got 1? There we go. 1's my final answer. A lot of people probably thought they got the wrong. All right. State the range of the graph below. Just range. Just need the y-coordinates. Worth a mark. Looks like we got a horizontal asymptote. Boom. Well, you know, I bet a lot of people missed that one too. And check it out. We got a point of discontinuity. POD. Y is equal to 1. I think that's it. I'll do it in both ways so that you see your answer. Please don't do it in both ways on the exam. Choose one way and do it, because if you get it wrong one way, I have to mark you wrong. So I'll do this way first. I'll do my favorite way, the nice little interval notation, -infinity, all the way to 0. We're going to union that with the other side of 0, go to 1. Then we're going to union that with the other side of 1 and go to infinity. Excuse me. Other way to do that, this is a nice way. The only thing that you have to remember about this is that you're using the y-coordinates. So that, you know what? Oh, brilliant. Y is an element of the reals. Check it out, such that y cannot equal 0 or 1. And we're done. I don't know, whatever. Do whichever way you want. I like this way just because it's fun. You get to use cool math symbols, cool math games. But other than that, it doesn't really matter. Just make sure that you have the restrictions in here and you're using the proper notation, because that's an E8 error if you're using the wrong brackets, curly brackets all the way, because we have our horizontal asymptote here and the point of discontinuity over there. Done. Ooh, that's a nice one. 2 marker. Sketch. Right on. This function. I don't know what it looks like. Factor. Like, it's like when in doubt, just factor, and like something will pop up. Factor correctly, I should probably say, over x. Okay, now again, don't want to do any reduction yet, because if I simplify, I lose generality. I could screw it up. So let's talk a little bit about what we can get from this. First off, VA. Yes. Is there a VA? Oof. No. There is a NPV, though. NPV, x is equal to 0. I don't know if this is a VA or a point of discontinuity yet. Don't know. I know it's a non-provincial value. I know that x can't be 0, but I don't know if it's a VA or if it's a point of discontinuity yet. So I'm going to say that. Do I have a horizontal, though? Horizontal asymptote. Degree on the top is larger than the degree on the bottom. None. That should be it that I have to do. I'm just going to turn that sound up. Okay. Yeah, I think that's all we can really do from this one. I'm going to simplify it out, though. Yeah, I'm going to simplify that out to be here, because I've canceled out the x's, and that actually becomes my point of discontinuity. No VA. No VA. Point of discontinuity x equals 0. I'm going to plug that in here to figure out my y-coordinate. There. So I have a point of discontinuity at 0, -5. Okay. Yeah, this is perfect. So I got 0, -5. 1, 2, 3, 4, 5. Open bracket over there. Now I'm just literally graphing f of x equals 2x minus 5. I'm already at my intercept. I'm just going to follow it up. Yeah. 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. I should probably have a ruler, but I don't. 1, 2, 1. There is no horizontal asymptote, no vertical asymptote, so I'm just going to... That's it. That's a almost kind of a nasty question, just because there's no vertical asymptote. Okay, let's keep on going with this. State a possible value of n for the polynomial function. This has a range of 0 to infinity. Okay. Two things you got to remember. N equals 2 and 4, 6, just evens. So this... no, see, now I'm thinking domain. Range. From 0 to... No, that would work then. That would completely work. N equals 2. That would be an answer. We could say n is equal to... Hell, we could say n is equal to 0. Yeah, we could say n is equal to 0 for that one too. N just has to be even. Yeah. Explanation here. This is what a graph would look like for a polynomial function that has degree 2. Degree 4 would have some sort of a form like this. It could be up or down, whatever. But as long as it doesn't cross these lines, that has to be an even function. Because this is not starting below the x-axis and going above it. This is only starting above the x-axis. So it has to be an even number. That's an interesting one too. I like that question. Okay, sketch the graph. This is an exponential graph. It has a base of 1/2, and it looks like we're doing some sort of a horizontal shift. So let's go ahead and let's get my base stuff down. I'm just going to go ahead and put it over here. I'm doing nothing to my y coordinates. I'm only good at x plus 1. Yeah, that's it. Okay, good to go. So let's go ahead and let's get some base coordinates out. First off, we're going to have a base coordinate for y is equal to 1/2 to the power x. There we go. When x is 0, my y coordinate is 1. When x is 1, I have my base coordinate. If I wanted to, I can give another one out because it looks like it's going to be a decreasing function. And we're going to see exactly what's going to happen afterwards. Now, later on, I should probably also put it down here, is that I will have a horizontal asymptote y is equal to 0 down here. Let's go ahead and let's give out my my transformed graph 3, 1/4. Okay, just going to pop these down. We got 1 and 1, boom. We got 2.5. And we got 3.25. Now, here's a nice little thing. It's not actually showing that we have to label out our x or our y intercepts. But if we pass it, we have to show it. That's the rule. So there's a cheat where we can whoop and then just cap that off right away and just be like, okay, we're good to go. But we really should let's go ahead and let's give our intercept as well. I'm gonna go ahead and let's put my horizontal asymptote down. That's you have to do this no matter what. But I do want to get a value. I want to sneak one in right here. -1. We get 2. So this is going to be 0, 2. And there, I feel a little bit better like that. So I'm just going to go ahead, connect up my dots, and boom, done. Arrowhead, that's it. Okay. Oh, my other cat has come to join. Oh, hello, Artie. That's not the right pause for you to be right now. Well, looks like I didn't get this exam done in an hour, but that's okay. We're going to keep on going because it's fun. We're going to solve. Why not? I'm going to say this. X to the power 3. I'm going to turn 27 into base 3 to the power 3. I'm pretty sure x is just equal to 3. Done. Ah, the question that everybody hated. Sketch 2 periods of y is equal to 10x. Yeah, it was one of those things that's like, well, if you didn't know it, then you didn't know it. Which sucks, but that's kind of what we got. Let's go 0. Let's give This one's a nice one. We'll do pi by 2. I'll do negative pi by 4, negative pi by 2. We know tan at 0 rads is 0. We know tan at pi by 4 is 1. We know tan at negative pi by 4 is negative 1. We know tan at pi by 2 is an asymptote. It's a non-permissible value, and it's a vertical asymptote on the graph. So we get to follow it up like so. There's one period. We have to copy paste this one time. It sucks. It sucks so much that this one was on it, and it was really only if you knew it, then you got it. And if you didn't, then you were kind of screwed. And it sucks. It definitely did suck. Let's go 3 pi by 4. Over here, 5. Ooh, not 5. What am I saying? We got pi by 4 here. We got that. No, that's okay. This should be a 5 pi by 4. And then over here would be a 3 pi by 2. There we go. So we're going to go ahead and pop another asymptote going down here. We know that tan at 3 pi by 4 is going to be negative 1. Tan at 5 pi by 4, because that's the third quadrant, is going to be up there. And boom. And that's it. 2 periods, done. 1 mark is giving the appropriate asymptotes, and 1 mark is having the form of tan x. Okay, 1 mark. Given the graph of f of x, determine the domain. Okay, of the reciprocal. Well, that means that these x-intercepts are going to become vertical asymptotes. Everything else is fine in it, actually. This is my x is equal to 2, x is equal to negative 2. Everything else is fine in this. I can still draw my graph from this. It's fine to have negative values. I just got to know that these intercepts turn into vertical asymptotes when I take the reciprocal of it. So my domain, negative infinity all the way up to negative 2, unioned with the other side of 2. Oops. Going to positive 2. Then unioned again with the other side of 2, going to positive infinity. Or I could say that x is an element of the reals such that x cannot equal negative 2, nor can it equal positive 2. Yeah. Okay. So that would be that one. Again, either or, choose one type of notation to use. Don't use both, because then you could run into an error of screwing up one of them, and then that's it. Okay, determine the value of a, b, and d of the sinusoidal function. 3 marks, 1 for a, 1 for b, 1 for d. They'll never give you all 4. They'll have to choose 3 out of them to do that, and they won't ever give you a b and a c together. They'll only give you one of them. So this is a nice one to have. Okay. It specifically wants, okay, so in the terms of a sine bx plus d. Let's go ahead and let's just straight up, we have our midline right off the bat. So that d is going to be equal to positive 1. That's easy. Our amplitude as well is going to be 2. And this is going to be our a value. Now we have to ask ourselves, does sine go up usually? And it does. So we would just say it's 2, not negative 2. And now all we have to do is figure out my b value. But b has this very nifty relationship of saying it's 2 pi divided by my period. And it looks as though this period is 10 pi. So putting this in equals 1 over 5, 1/5. Now I'm just going to look at that one more time and make sure that we're all good to go for that. Yeah, that's it. Okay, good stuff. 3 marks. Plugging away. Determine if the point this is on the unit circle. Based on the definition of a unit circle, you got to know this. X squared plus y squared equals 1. Here's my x, here's my y. That's all we got to do. Equals 1. We're going to get a 7 over 25 plus 4 over 25 equals 1. I guess I should kind of put maybe a question mark there, because we're kind of testing that. And this does not equal 1. It is not on the unit circle. And our justify is literally since x squared plus y squared does not equal 1. That's it. That's your justify. Yeah, that's it. A couple easy ones after, a couple hard ones. I think I remember this being a pretty fair exam. Nothing crazy about it. Except that one, what did he do wrong question. Solve algebraically. Sure. Straight up from the definition. NCK equals n factorial over n minus k factorial and, NCK. NCR, sorry. R factorial. I'm just going to make sure that that's right on my, yes it is. We're using an R combination. Okay, so let's put this down. We got n factorial divided by n minus 5 factorial multiplied by 5 factorial divided by, let's see what else. N factorial divided by n minus 4. Oh, we're going to have to use some nifty algebra, I have a feeling here. Equals 6. Okay, pretty much after this, we can just start doing some cancellations. This is absolutely good to cancel it with that. These two are actually going to knock each other out and just leave a 5 instead. Yeah, so in the end, n minus 5 factorial multiplied by 5. 1 over that, all over 1 over n minus 4 factorial multiplied by 1, all equals 6. Let's go ahead and uncomplicate these fractions. This gets sent to the numerator and denominator. This gets sent to the numerator and the numerator. So we're going to get n minus 4. Oh, I'm off the page. N minus 4 factorial divided by minus 5 factorial 5 equals 6. Yep. Couple more things that we got to do here. Almost done, but not quite. We're going to have to expand once. And that's going to actually get rid of my n minus 5 factorial on the bottom. So this is going to be n minus 4. Then I would multiply that by n minus 5 factorial, which cancels out that one. Equals 30. After multiplying by 5 on both sides, I'm going to add 4. Add 4. 34. It doesn't seem unreasonable. We don't have a calculator, so we can't check it out. But, sure. Let's go with it. Ooh. Okay. So that one. Keep it going on. Right. Given sine alpha is equal to 4 over 5, where alpha is in quadrant 2, determine the exact value of sine 2 alpha. Well, that's interesting. So we're going to need to figure out sine 2 alpha is equal to 2 sine alpha cos alpha. So from that, we already have sine alpha. We just need to figure out what cos alpha is. And we know we're in quadrant 2. Make a triangle. Boom. We got our y coordinate, and we got this, and it happens to be a 3, 4, 5 triangle. I don't even need to do the Pythagorean theory. You can off this side if you need to, but we need to remember that it's a -3 because it's in quadrant 2. So that's going to mean that cos alpha is equal to -3 over 5. We got the 4 over 5. We got the -3 over 5 equals sine 2 alpha. We're not solving for alpha here. So let's go ahead, and 2 times 4 is 8 times -3 is -20. Oh boy. -24? Yeah. Divided by 25. That's our answer. Cool. Approaching the end, actually, I think, here. Question 40. Actually, not really at all. Got a couple more to go. Not too bad. Got like a little over 10 questions. What time I'm at? I'm at an hour and 19 minutes. Not too bad. Given the functions f of x, x plus 1, g of x, square root of x, determine the equation of... Okay, so this stuff we haven't done yet. This is our next unit, but hey, I'll show you. It's really easy stuff. Essentially, all we're doing is plugging our f of x equation in for x. It's really all we're doing here. We're saying g at x plus 1 equals square root of x plus 1. That's it. And now it just wants the graph of this. We really don't have to talk too much about restrictions, just because we should know just kind of like our restrictions based upon this. So all I'm just going to do is transform my root x graph. This is going to be my root x graph into x plus 1. And that just means that I'm going to take off 1 from every x value. So that's going to start at 0, 0, 1, 1. My next one is going to be 4, 2. I think that should be good enough. We got negative 1, 0, 0, 1, and we got 3 and 2. Okay, pop this on a graph. We're good to go. Negative 1, 0. We got 0, 1, and we got 1, 2, 3, 1, 2. And slam that arrowhead on it, and we're good to go. Done. Well, we'll be doing a little bit of that. Well, that's our next unit, and that's going to take literally 3 days. It's a very, very short unit. Steve is asked to determine an equation with a larger period than the period of the graph of this. Justify why Steve's answer of this is incorrect. Well, we can just justify it by actually calculating it. Period of Steve's equals 2 pi divided by b equals pi by 3. Period of cos 2x equals 2 pi divided by 2 equals pi. Steve has a shorter period. Done. Just justified it. There's our justify. That's it. Don't have to explain why it's wrong or anything. Just justify it, and there we go. Okay, given the graphs f of x and g of x, determine the value of f multiplied by g at 1. Again, new unit, haven't done it yet, but quite easy to do. All we're doing here is we're taking f at negative 1, and we're multiplying that by g at negative 1. F at negative 1, we look on the f of x graph. Here is f at negative 1, and it corresponds to a y-coordinate of negative 1. What is f when x is negative 1? Well, f when x is negative 1, f of x is negative 1 as well. That's the y value. G at negative 1, this y-coordinate equals 1, 2, 3, 4. So we're just multiplying these two y-coordinates together. Again, new unit, should know. Hold on. Could you also just look at the b value for the last question, determine if he was wrong? So it would depend on what your justification is. So if you said his b value was greater, therefore his period would be shorter, that would be an acceptable answer, because you understand the b value, a higher b value doesn't equate to a bigger period. So you could say that. You would just have to word it in a way that you show that you understand that since b is higher, then the period is shorter, if that makes sense. So just justifying it in that way. Equals negative 4, good to go. Determine the value of g at f at 0. We have to figure out what this value is first. So f at 0 on our graph looks to be 1. So then we just plug this in. You're going to see how easy this next unit is. And then g at 1 seems to be 2. Y is equal to 2 in there. Equals 2. That's it. Very easy. Okay, 3 marks. Sketch the graph. P of x equals all this good stuff. Okay. Let's get a couple things going first off. We know degree. It's making me review a little bit. Degree is 5. So right away, and we have a leading coefficient. Leading coefficient is negative. So we're kind of going in this path here. We're going to go from our quadrant 2 to our quadrant 4. And Artie is going to say hello again. Hi, Artie. Yeah. Okay. Maybe not. Okay. So he's going to go from quadrant 2 to quadrant 4. A couple other things that we should recognize here is that we are going to have some x-intercepts at -1, x-inties at, -1 would be S1, 3 would be another one, and we would have 1. However, this one has a multiplicity of 3, so it's going to be a little curvy curve. Let's put this down. We're not going to have a y-intercept, or it's going to be 0, 0, so that's okay. Actually, no, it's not. Nope, it's not. So let's do a y-int right away. X equals 0. So p at 0 is going to be negative, -1 to the power 3, -3, and 1. So we're going to get negative, -1, -3, 1. That looks to be -3. Those are going to cancel? Yeah. So we'll have a y-intercept there. I'm going to put that down. 1, 2, 3. We're going to have an x-intercept, I said, at +1. I'm going to try to keep my scale somewhat consistent. I've already kind of kiboshed that with my y-axis, but that's okay. I'm labeling stuff. Oh, there's my cat again. There we go. Now, from this, I know that I have to start over at my second quadrant, end over at my fourth quadrant, because I got another, again, degree of 5 and leading coefficients negative. So I know I got to go through these points. This is a multiplicity of 1, so I'm just going to kind of go through there. This is another multiplicity of 1, so I'm going to go through that way. Now, I'm going to pass, but I have to do a weird, like, curvy thing. I'm just going to make sure that curve is there. Let's go ahead and start this up. Going to go down. I just want to go through this, so I'm going to go through that one. Back up around, back down, and hey, there's my graph. Label. It doesn't say it, but you're going through it, so you should label it. And that, got a communication error in book 1. I didn't label out my y-intercept back there. I already know. This is my exponential graph. I didn't. 0, and this one is 3, 0. Got my arrowheads, got everything else on it. Good to go. Gives you a +3, -3. You corrected my work? It is -3. Still -3 times 3 gives you a +3. No, it's -3. What are you talking about? No, Jacob, you're wrong. It's -3. Gonna go ahead and plead the fifth on this one. My work is right. Now you're causing me all confused here. That's good. This is good. This turns into a +1. I'm good. Yeah, you're right. Yeah. Well, that's what I got right here. I got -1 to the power 3 is still -1. I have the negative from the leading coefficient. Yeah, okay, but I still have a negative from the leading coefficient. So it still should be a negative. I have 3 negative signs. I don't know why I'm explaining this so much. I have 3 negative signs. It's going to be negative. Oh. Get in the game, son. All right. Okay. Okay. Even if you did that, I'm trying to think. I don't need your input. I love chicken. Would your graph work? No, that would be like a degree of 4. So you'd lose a mark if you did that. But then you wouldn't be able to do the same intercepts. Like you would know that something is weird if you tried to do that. So anyways, Good discussion, though. The point, negative root 3 comma 1 is on the terminal arm of an angle theta in standard position. Determine tan theta. Well, sure. Tan theta equals y over x. Really? They have this as a question? Hello, Luna. Done. That's my cat. That's my cat right now. Yeah. Hi. Yeah. No. Yeah. Yeah. So that's my life right now. Yep. Thanks, Luna. Thank you. Okay. Back here. No. Round 2. What's the pets? Hi. Trying to do some work. Okay. All right. Back here. So we got tan theta is equal to that. Don't have to rationalize the denominator, so we're good to go on that. Determine a possible value of theta in radians. Interesting. Okay. So it... Thank you. Just gonna... Hi. Yeah. Get the hell out of here. We got to figure this one out. Determine a possible value here. This is terrible. This is actually terrible. How many of you guys would know how to do this one? Yeah, I know, PETA, I know. Now, we got to ask ourselves, we don't have a calculator for this one, right? We have no calculator for this one. And they're asking us a possible value of theta in radians here. Guys, this is an exact value. Unfortunately, we wow, really? That's incredible. I don't think I remember seeing this question on that. We actually have to know that this is an exact value of... I don't know how to answer this question other than you have to know that pi is in the... or theta is in the pi by 6 family. We don't have a calculator, so you can't solve for it in the normal fashion. You would have to know, or you would have to realize that this is in our exact value tree. I'm not happy with that. Anyways, it's negative, so it has to be in quadrant 2 or 4. So theta could be 5 pi by 6. Or, and you would just choose one of these answers. 11 pi by 6. Interesting. If you got another way, if you ever figure out another way to do that question, I'd be down to see it. It would be in the marking guide if there was another one. I don't believe there is. You just have to know this exact value. That's kind of trashy, though, to be completely honest with you. That's kind of trashy. But you would have to know that, one, we don't have a calculator, and then just try your exact values. I don't like that question. Okay, let's keep on going, though. Describe the transformation used to obtain the graph this, given the graph of this. Definition. You would take the inverse. And isolate for y. Done. That's it. There's really no other thing that you have to do there. Use Pythagorean theory to get... Hey, that's a nice idea. I like that. Okay. Man, I'm going to have to eat my shoe if, I don't get the same answer. I like that. I like that a lot, actually. Didn't even think about it. Negative root 3, 1. This would be... That'd be 2, right? X squared plus y squared equals c squared. We get a root 3 squared plus 1 squared equals 4. Yeah. Okay. Yeah, so then you would get that as well. Not terrible. That's not bad at all, actually. So with that one, then, you could get your... If you could put it on the unit circle, you could say that this is going to be... negative root 3 over 2, and this would be negative root 3 over 2 and 1 over 2. This would be my cos theta, and that would be my sine theta. Yeah, there you go. Nice work on that. Yeah, that could be, yep. Or you can know your exact values. There you go. Wow, but if you did it this way, right? if you did it that way, here's your conversation. Damn, worth 1 mark, hey? You would have to set up your triangle, put it on the unit circle, right? And then figure out that those would both be exact. Either way, you got to know your exact values. Interesting. Cool question. I imagine, well, I don't know if a lot of people got B wrong or not. It depends if you know your exact values. That's a nice one. I like that one, though. Good eye there. Regardless, going back to over here. Solve sine theta. Oh, geez. Here's your smoking gun, though. Boom. We need general solution. We're always looking there. We don't have a calculator, right? We have to know this is the exact value. Don't have a calculator, but we do need the general solution. I'm a fan of radians, so I'm just going to keep on going with that. However, we could answer in degrees if we wanted to. So yeah. This would be our pi by 3 family. And we're in quadrants where it's negative 3 and 4. So we would say theta equals, and we would say that in quadrant 3, this is going to be 4 pi by 3 plus 2 pi k. And in quadrant 4, that would be a 5 pi by 3 plus 2 pi k, such that k is an element of the integers. That's it. You can even use this notation if you'd like to. If you're splitting it up, then you would need to make, theta equals this, theta equals that, and then have k is an element, or you can just kind of do it like this. That's fine too, as long as you get both these ones here. 1 mark, 1 mark. I don't even know what that would be in degrees. 300 degrees and 240 degrees plus 360k. Okay, given the point AB is on the graph here, describe how you would determine the corresponding point on y is equal to square root, f of x. So your xy in f of x, right, whatever that function is becoming root f of x, which means you're taking square root of your y coordinate. You got to know it's the square root of the y coordinate, right? There's nothing being done to x. There's nothing inside those brackets. It's saying describe. I would take the square root of the y coordinate b. That's it. You could even do this just to help you with you still need your description, but you could do this to help you if you wanted to. Done. Okay. This wants me to evaluate, but this looks like absolute trash. But it's worth 1 mark. So, I mean, it's a low value trash. We got to use the double. We got to use the sum or addition formula. Yeah, that's all we got to use. On a formula sheet, which one does this look like? Well, we're doing 2 coses, and we got a minus sign in between, so we're using cos alpha plus beta. Here's my alpha. Here's my beta. We're going to go cos alpha plus beta. Right, yep. Equals cos pi by 20 plus, I'm just going to straight up do this as my common denominator right off the bat. I'm not going to bother do anything more with that. This is going to be equal to cos 5 pi by 20, which is going to be cos of, oh gosh, making me work for this mark here, pi by 4. So this is going to be equal to root 2 over 2. Again, don't have a calculator, can't do this any other way. Got to know your exact values. That's it. Okay. Oh, actually, we're close to being done now. Describe the transformations used to obtain the graph of the function this thing from that thing. 80% of you are going to make this error. 80% of you. Whew. 4 out of 5 of you. Whoa. Okay. That's the most Twitch streamers I've ever had. Twitch viewers. Okay. We got a factor. Just straight up. That's all we got to do. Then everything becomes apparent, right? Factor. Okay. After that, describing, right? So we easily know what's happening. Horizontal reflection. We have a horizontal shift of 6 to the right. Wonder if I can, wait, does this work if I do this? Let's see if this works. Oh, this doesn't work at all. What am I even thinking about? Oh, wait, oh, does that work? Can you hear this now? So how do you do math? Vertical shift. We're gonna go down 8. Okay. That's it. That's it. All right. With that being said, there's our 1, 2, 3 marks again. Kind of gifted to us. You just got to factor it out. If you said this was to the left 6, obviously you wouldn't get that mark, but you would still get the horizontal reflection mark, and you would still have the down 8. So honestly, everybody should be getting 2 out of 3 on that one. If you didn't factor, then they don't like crucify you for it, but at least then you get that. Okay, state the equation to all asymptotes of this function. All asymptotes. It's worth 2 marks. Probably means there's 2 asymptotes. Let's do the VA first. 3x plus 1 cannot equal 0. X cannot equal negative 1 over 3. Therefore, x equals negative 1 over 3 is my VA. My horizontal asymptote, however, I have to figure out that my degree on the top is less than my degree on the bottom. Therefore, my horizontal asymptote is y is equal to 0. If you wanted to, I guess you could sketch that out for yourself. There's nothing stopping you. That's a grade 11 question, sketching it out. And you can just kind of verify it from there as well. On the home run here, or the thing that leads to the home run, the home stretch. Determine the zeros of the pond. Really? They're going to make me divide for the last one. They save these ones, hey? All right. List factors. Okay, we just got to list those factors of the last one there. So it's going to be plus or minus 1, plus or minus 3. And we're always going to try out your plus 1s first, just to see if there's a factor. So let's go P at 1. Oh, hell yeah, we just found it. Boom. Yeah, x equals 1 is a factor. Again, that's not the binomial, right? X minus 1 is the binomial, but this is what we're going to synthetically divide by. So we're going to pop that in. A little bit of synth dev. And we're listening to a little bit of synth wave. Okay. Let's go 2, 5, negative 4, negative 3. Let's pop down that 2. Let's times it by 1. What do I do? Do I add? Yeah. Those French people really screwed me up. They were like, oh no, we do all this subtraction and stuff. And I'm like, wait a minute, we don't do that. And then we didn't do it. Yeah, we're definitely just adding. Good. X to the power 0, x to the power 1, x to the power 2. So from this, we get P at x. And this is another communication error here. If you don't do P of x equals... determine the zeros of... No, if you don't do P of x, then bad things could happen. I would just keep this because you're making an equation. You're making an equation into an expression that doesn't make any sense. We're not listing the factors yet. We're just factoring them. Or we haven't listed the zeros yet. We're just factoring it. So you can't just drop the equal sign yet. X minus 1, 2x squared plus... Oh, they're going to make me do... They are. You got to decomp it now. Oh, wonderful, wonderful. Oh, I know why they're... No, I don't know why they're bothering me right now. Feeding time is until 6. Luna, I'm trying to do math. Yes, I know. Everybody loves you. You're a cute princess. I'm sorry. Okay, I'm sorry. Okay, sit on my lap. All right. Okay, you're gonna do some cat. You're gonna do some math with me. I swear to God, if you touch that microphone, cat. Hey. Relax, cat. Relax. Gotta relax. Doing this in my head right now because I can't write it down because I'm a cat. But we know that 2 and 3, no x on the 3x. No x on the 3x. Thank you. That was my cat's fault. I'm going to blame that on my cat. Thank you for catching that. Doing it in my head. But we can always write out the decomp another way. Just don't have time, nor do I have... Kate, Luna. Thank you. Okay. So we got that. We're going to factor out an x. Okay, factoring out an x. Good. Awesome. Going to factor out a 3. Ba-boom. Sick. You could, theoretically, do another round of synth dev. However, I think it just might be easier to do the decomposition here. Now, here's the thing. You only got 2 marks. So right now what we got to do is determine the zeros. X equals 1, -3, and -0.5. There's your final answer, right? Or, you know what, I'd probably give that a 2. Can I give it 2.5? I'm not sure if I can give that 2.5. I think I really do need to see this. These are the zeros of P of X. What does this make? This makes zeros. What values of X make that 0, right? That's what we got to do. Okay, determine the equation of the radical function represented by this graph. Interesting. I'm just going to draw the base radical function. 1, 2, 3, 4, 1, 2. Right, so we're coming from our base function, xy. So that's 0, 0, 1, 1, 4, 2. And this is something x and y. I don't know what yet. But this is coming from 0, 1, 2, 3, looks like. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 5. And it looks like it's a 4, 1, 2, 3, 4, 5, 6, 7. Well, I think we're very confident in saying that there is absolutely no horizontal shift. I'm really confident in just saying X there. We're good to go for that. Now, however, what's going on with my Y coordinates? It's not just a shift up 3. It's not just a shift up of 3. It has to be something else. Multiplied by 2, shift up by 3. That would give me that. This times 2 is still 0 plus 3 there. This times 2 is 2 plus 3 is 5. This times 2 is 4 plus 3. There we go. So just kind of linking it up. Now, this is the challenging part. We got to give the function. So we know that we're dealing with a radical x, and we're not doing anything horizontally, so nothing has to get paired up with that x. We do know that there is a plus 3 on the back, and there should be a 2, not a hard, challenging part. It would have been a harder, challenging one if we did have a horizontal stretch, because we would have to do whatever the opposite sign is in there over here, and the reciprocal of whatever that multiplication value is over there. It doesn't happen to be that bad, though. We could even verify this if we really wanted to, but I don't, so we're good. Oh, what? That's it. Sick. Under 2 hours, 100%, obviously. So that was pretty good. I don't know. That was pretty fun. Oh, that was pretty good. Poggers. Can I say poggers? Poggers. Knew Jacob was going to say that. Yeah, good. So that was pretty fun, boys. Possibly girls. I'm not sure. Apparently my cats want attention. I guess the pencil. So that's good. But yeah, so that was pretty fun. No. No, I don't want to do any more of these. I think I'm good. Like, I mean, we'll do study sessions at school, right? So we'll do some more exam stuff at school. But in terms of me just, doing this, like separate to work on, you can always download them. I'm not going to print them off at school, but you can always download provincial exams off the website, and you can work on them. I can show you those. But I do have all the exam stuff is online. In terms of like my exam reviews, they're all up there. Just use the drop-down menu under our class stuff, and you should see exam review, and that should all be there. So you can take a look at that. But we will talk more on Monday. So thank you very much. Have a great rest of the holidays. See each other on Monday. I have a land tomorrow, so it's going to be great. Circle below the waist. Got him. You're going to get banned. All right. Anyways, ciao. I guess I'll upload this to YouTube or something in case anybody else wants to watch it, but that's it. All right. Ciao, guys.